Hello and welcome back to our next episode. We have Krishna back with us. Hello, Mr. Krishna.
Hello, very good morning.
So, in a previous episode, we had a great conversation on the automobile sector, right? Post that, I was going through one of your latest blogs, and it happened that I saw a particular word or an incident. It was about the Tacoma Bridge. What do you have to say about that?
Of all you hit upon this subject, this is an all-famous goalpost in history that anybody who wants to talk about a structural failure, a large civil structural failure will refer to this. We can talk more about it.
So for those audience who are less familiar with this, can you give us a short briefing on this topic?
Yeah, well, that's a big story, but I had to shorten it as much. So this is a US made bridge there, and they constructed it like 75, 80 years back, and that was then I'm talking of. Everything was right, and they assumed that everything of the design, detailing, construction was all in place. But as they started using, they started feeling, at least the people who started using, people who are crossing, started feeling the perception of some kind of oscillation, which is like low frequency motion. Post that, some vehicles played on it, and then they could see that this is really a serious thing that's going on. No sooner this was observed, people were put off from the bridge was made as not usable. But soon the vibrations that were initially observed picked up a lot, amplified by itself for various reasons, and finally collapsed. And that's the fastest story about this Tacoma Bridge.
Okay, so apart from this, what are the common sources of vibration that a structure can encounter?
In case of, if you are referring to the Tacoma Bridge, then there are various theories around, even though none could be fully proven to a single source of failure. But this being a bridge which is exposed to all the elements, first thing somebody doubts is on the wind-induced energy, which should be one of the causes, because without any of the inducing of forces onto any structure, this would not have probably happened. So the wind started whatever 10, 11 miles per hour speed of wind that was passing, crosswinds. So the motion started, the bridge started oscillating, but it also slowly picked up an amplification that the same vibrations or the oscillations start becoming more and more. And then we use a word called the shape of the bridge. So what could be a sway initially started becoming twisted motion, and at some point the failure. So aeroelasticity is one thing that people say about wind-induced energy, and then there is something called NEXT, which is the same as what I'm saying called natural excitation. Put together, the structure loses to have any damping, which is a controlling method to stop its vibration. In the absence of damping, everything failed.
So in your day-to-day work, you encounter such incidents like in the normal structures that you see?
Scale wise, yes and no, may not be of this. If that is the scale, then usually it would have fallen. But may not be our cases. We do see there is this structure in Taiwan called the Taipei 101, which is oscillating quite a lot, but it has a lot of control mechanisms have already been put into. Even in our consulting work, we see vibrations perceived by human or vibrations of order which they think that structure can have some problems. So we do encounter such things.
Okay, how do you typically figure out if a structure vibration is just some kind of annoyance, or is it something that is dangerous to the building?
There's already a well-defined guideline. There are standards, we'll come back to that, but there is first set is the human who is the best instrument. So as soon as you walk, like you get into a ship, you start feeling the motion, you get motion sickness. So human sensors, human body's perception is the first thing. So once it crosses, there is the engineering limits as well and the perception limit. Then the building also can have damage. So both is possible.
Okay. So talking about the methods, what methods do you use to identify the situation or the structure's vibration behavior?
Okay, if the design is already done and things are already in place, like most of the cases that we attend to, there's not much that you can go back to simulation, do some modeling and all that. But once the physical bridge or the physical structure is there, most of it is a test-based approach. Usually you go into of studying the structure's design, strata data, bore log data, which all plays a role in the foundation quality, post that the building quality or the build quality of the structure, and then implement test plans which suits to case. Most of it, like you first test the background vibrations, and with some excitation, what happens, you may conduct some bump based testing to induce control force and find out. Finally, to identify what are the natural frequencies that the bridge gets exposed to or reveals, and how dangerous are they. and then further guided by a lot of standards.
So we often heard about this term called resonance and dynamic amplifications, right? So what are the considerations that has to be given to this when you pre-plan or design the structure?
A lot. Maybe we are a noise vibration consulting company, but we are quite fast moved into understanding structural integrity requirements. One is all the static load calculations. Two is how this should be when it is subject to a dynamic load. In my experience, I believe no structure is supposed to be considered as static. However static they look like, they are exposed to some kind of forces. So a good consideration is to be made at design stage, which one of the most important thing is to avoid natural frequencies that come into the operational usable frequencies. Like 100 people are walking, you already know some kind of hint on what kind of frequencies this could be. So estimate that, see that they don't coincide with the natural frequency of the structure. And rest of it is building on the stiffness, the mass and everything else, which returns to the basics of the formulae.
So for the buildings which is already exhibiting some kind of vibration issues, what are the methods or how do you address it? Address the issue?
Yeah, so I just touched upon that studying the design would definitely help, and check on the usability of this building. Not all buildings with some kind of, one thing is for sure, all buildings all large structures do vibrate.
Okay.
And amount of vibration is to be allowed and it is required. You can't make it so rigid that it will break down somewhere. So taller the building is, there will be low frequency oscillations. Are they within the limit is one thing that to check at the design. But as we walk in as a consultant, we will really measure, look for damping values, maybe calculate dynamic stiffness. If at all there is a possibility to do something of a mitigation plan, it may be very hard, that we have attended multiple of it, but it is a possibility.
That was a truly good insight from you, Krishna. So to all our audience out there, I hope it was as interesting as it was. And also I have something to ask Mr. Krishna back again. I heard that you're going to have a paper presentation soon. Is that true?
It is true, and however you got to know about it. Yes, this is a forum in London for which I'm a member. This is a reputed institute called Institute of Acoustics. There we are presenting, there's a seminar coming up in October, and our paper is, as in Dynamics, the paper is accepted, and I'm presenting a large machinery vibration case in that symposium.
Okay.
Thanks for asking.
For the next episode, I have something cooking up.
Yeah, sure.
We'll get back to you soon.
Thank you very much.